Today we are talking about the law of sines. All right, so the first thing that I want you to notice is that our uppercase letters are angle measures. So our angle measures are uppercase letters, which is why these uppercase letters, or the angle measures, are inside of the sine value. The side lengths across from angle A is side A, lowercase a. Angle C, side C. Angle B, side B, all lowercase letters. And so what is happening here with law of sine is that this is true of any triangle. Normally with sine and cosine and tangent, we could only use that for right triangles, but this works for any kind of triangle. And so the ratio, or the fraction between the side length and its matching angle measure, or sine of the matching angle measure, is the same as the ratio for any of the sides with sines of the angle measures. And so that is true always. And so one thing I want you to notice is that each of these are actually the same. And so you may want to pause the video here and write both versions of these down, because sometimes this one is more helpful and sometimes this version is more helpful. And so I will give you this on the test, just like I will give you your identities on the test. I will give you all of the reference things kind of in a box at the top of your test, and then you guys will be able to just apply all of these things to whichever problem. Okay, so let's see how this plays out when we use it. And so first things first, if I'm giving you information, I always want you to draw a picture. So you can just draw a triangle, doesn't matter what your triangle looks like, and then you're going to label A, B, and C. Angle A is 45 degrees. Angle C is 28 degrees, and side B, the one across from B, is 120 units, the side length. And so in order to use law of sine, you cannot have all the sides. You cannot have all of the angles. You need at least one matched set, a side and its matching angle, in order to use law of sine. And so what you may notice here is that this angle and this side, this angle, this side, this angle, this side go together, but none of those things match together. But if you remember from geometry, 180 degrees minus 45 minus 28, where all of the angles are going to add up to 180 degrees. And so we can subtract these angle measures from 180 degrees, and we get 107. And so this angle measure here is 107. And so now I have a matched set for using law of sine. So are going to be this angle with its matching side and this angle with its matching side, but we don't know what this one is yet. Okay, and so we're not always going to use all three things. We're really only going to use, or all three parts of the equation. We're going to use just the first part and the second part, or the first part and the third part. We're going to use a combination of only two sets of the equation. So if we go back to our law of sines, we're using like this one and this one. We're never going to use all three at the same time. So here, I am going to set up my equation. Sine of 107 over 120 equals sine of 28 over the C value that I'm trying to solve for. And so hopefully you just noticed that this is a proportion, And so you can multiply, cross multiply, and so then this turns into c times sine of 107 equals sine of 28. So 120 times sine of 108, 120. And so then we can divide by sine of 107 over sine of 107. And so the way that I like to type things like this in the calculator, just so I don't make any mistakes, I type the first part in, and then I type the bottom part in, and type those in separately. And so you guys are going to be able to use the yellow calculators, but it's I don't have a yellow calculator on my computer, so I'm going to use Desmos for us. And so we have sine of 28 times 120. And in Desmos it's easier to do like times a fraction or divided by things. So sine of 107. And so you do want to make sure that your calculator is in degrees, but what you should get on this one is a side length of, so that goes away, and C is now all by itself, and so 58.9 should be our side length. All right, so we have another triangle, ABC. And angle A is 32, side A is 20, angle B is what we don't know and what we're solving for, and then 3.5 is that side length. And so I want to set up this problem and show you, because before we solved for a side length, this time we're solving for an angle measure. And so here I have, I'm going to just put the one that I'm solving for first. So sine of B over the side length that matches with it, 3.5, equals sine of 32 over the side length that matches with that one. And so I can do the same thing here. I can cross multiply, and so I end up with 20 sine of B equals 3.5 times sine of 32. Divide by 20. And so now my equation, sorry, I'm coming up here. Sine of B is equal to 3.5 sine of 32 all over 20. And so what I hope you notice here is that B is not by itself yet. And so if you remember back several weeks when we were trying to get B by itself, remember you have to do the inverse operation. So just like adding and subtracting are inverse operations, multiplying and dividing, inverse operations, sine and inverse sine are inverse operations. So whatever I do to one side, I also have to do to the other side. So I'm doing inverse sine of the whole big fraction to get B by itself. So let me show you what that looks like. So we have, in your functions list, you have inverse sine, and we want a fraction inside of that, and our fraction is 3.5 times sine of 32. So 3.5 times sine of 32 all over 20. And so we end up with an angle measure of 3.5. And so we are rounding everything to the 10th place today, I believe. So 3.5, 5.3. 5.3. So we have 5.3, and then make sure that if it's an angle measure that you're putting degrees with that situation.